So I would like to ask the panelists to come on the floor. Good afternoon, everybody. Please take a seat. So this first roundtable is on AI, robotics, and defense challenges. Please. Bonjour. Comme vous voulez. All right. So, of course, AI and robotics are very linked, and the new challenge, probably the one that we did not expect to happen, but that happened, is the defense challenges. So to talk about this, I'm really happy to have all my panelists with me. Maybe you can introduce yourself quickly so that it's going to be easier for the audience to better know you. Let's start with you, Sandra.
Hello. So good afternoon. I'm Sandra Budimir, founder and general partner at Expansion Venture. Expansion Venture, it's an investment fund dedicated to early stage startup with aerospace and defense applications. We raised 140 million funds so far and have already 24 lines of investment in space, aero, and defense.
Thank you. Philippe?
So good afternoon, everybody. So I spent many years within DGA, so the French Procurement Armament Agency, where I was heading, piloting major European collaborative programs like FCAS, Future Combat Air System, or the Main Ground Combat System. And I joined Capgemini Invent a few months ago, where I would say I'm the global head of AI for defense.
Thank you. Cordelia?
I'm Cordelia Schmid. I'm a research director at Inria, and my work was traditionally in computer vision. So before any AI was there, worked in computer vision before anything worked. And so more recently, I've gotten into obviously using LLMs and computer vision in parallel, so multimodal language models. And then I'm also interested nowadays in robotics, so to see how vision can be used, all these models can be used in the context of robotics, and then also to see how machine learning can help improve robotics models.
And you are a Prairie chair.
Yes.
You hold it. And Josef, who was a former Prairie chair.
Yes. Thank you very much for the invitation. My name is Josef Sivic. I'm a researcher at the Czech Technical University in Prague. And before moving Prague, I spent more than 10 years at Inria in Paris, and I was one of the AI chairs in the first Prairie Institute. Thank you for the invitation.
Antoine?
Yes, Antoine Bordes, thank you for the invitation. I'm the chief scientist of Helsing, which is a European defense company whose main value comes from AI, software, and hardware. And before that, I worked at Meta, Fair Laboratory, for almost 10 years.
So thank you very much for joining. So let's start with the first question. So AI and robotics are, in defense in particular, are really facing unique technical challenges because of the real-time decision-making constraint and the robustness in adversarial environments. So Cordelia and Josef, probably you can start with a question. What are the most pressing technical hurdles you see or you try to solve in your research, which will probably unlock the new capability for defense?
Yeah, I would say basically what's most important in any environment is that the robot can really knows what's happening in the environment and then can interact and plan accordingly. So this is true if you have a robot in a household. You need to really understand what's going on, where the objects localize everything, and obviously if there are terror attacks, it's even harder to localize these objects, but even if you have changes in lighting conditions or changes the objects move, it's already hard still today to localize it in a way which is sufficiently reliable to interact with the environment. And obviously if you're in a terrain which you have never seen before and you want to navigate there, it gets even harder. You have to see what are the depth maps, how to reconstruct the environment reliably. And then the second component is obviously how to plan and how to make things robust and explainable.
Josef?
Yeah, so actually before coming here, I had a chance, or I discussed with my colleagues in Ukraine what they see kind of as pressing challenges at the moment on the ground. And what was interesting, what they mentioned is that what I mean, you see, or we know for a time how the aerial unmanned aerial vehicles, the drones, are very important on the battlefield at the moment. But what they mentioned, what has increasing importance and role on the ground are the unmanned ground vehicles. So which are really like you can think of drones with wheels, and are increasingly used for the sort of last mile logistics to deliver supplies, because you can't get to the sort of front line by car anymore, almost, or evacuate the wounded. So they said this is the thing which is now up and coming. And they said that the challenge is a lot of it is still operated at the moment, but that sort of because of the constant jamming, it's important to get at least some level of autonomy. So the issues like navigation, and which we see are also research problems in these difficult conditions. Imagine off the road, in night. So all these are things which actually they also are open research challenges and are also happening in the real.
And what we have to highlight is that there's no GPS or nothing like this that they can rely on. So the autonomy of these vehicles has to be very high. Can you explain this?
Yeah, so because of the jamming, you cannot use GPS. You kind of have to rely on some sort of visual navigation. Even you can get some teleoperation, say via a aerial drone, which can help to transmit some signal, or you can get some maybe local autonomy, so that the vehicle can go around the trees by itself, based on visual information from a LiDAR or a pair of stereo cameras. But sort of or you can use like a local based on navigation without a GPS, based on just measuring how far the drone went in different directions. But it is still a challenge, the navigation.
Thank you. Antoine, how does Helsing prioritize R&D to address these challenges?
Yeah, so it's quite a challenge, because the situation Josef was describing super well. If we had done the roundtable 1 year ago, I think you would have highlighted the same challenges for flying drones. And now we go to drone on the ground, and next year will be something different. So if we want to be relevant in the conflict of today, and Ukraine is the biggest one, the speed of innovation is to be actually really, really quick. Because what Josef is mentioning is not something that they think in the university they should be doing, something that they need on the ground more or less now or yesterday. So how do you, and he also said, and both of them said, that these are more or less like research challenges right now. So you face challenges where you have basically fundamental research challenges that need to be applied on the ground almost one day after, or something like that. So this is super quick speed of transfer. And what we've seen at Helsing is that basically this speed of transfer is something that makes the difference. So if you can, as a company, as a country, as an organization, if you can get faster at this, you actually get an advantage on the field, because you have something that they can't see. The jamming that you said was a good one. The first one that could navigate without GPS, well, they could get further along than the other ones. The other one catch up, and then you can maybe communicate with much lower bandwidth radio. Okay, the other one can't. When they can't, then you can actually get level of economy. Maybe you just need to send one message every hour, etc. So this stuff is really this cat and mouse. So for us at Helsing, trying to adapt that is basically twofold. We try to be very, very close to the subject matter. So we've been in Ukraine for the 4 years of the company almost. Not that we are deployed all the time for everything, but also that just to get this intel at the later stage, not to learn it like 3 or 6 months later, right? You need to get this, to also have access to the real conditions, the real actually, the real deal, where the real conditions about where this is complex. This is one leg. The other leg is like we try to invest actually quite so much into R&D, pretty fundamental. We don't communicate much about it for many reasons, but we actually have almost 100 researchers now that are working on some of these topics pretty deep. We are that close to have our first partnership with Inria to work on some of these topics. That close. It's in the hand of some lawyers, and but everything is set, so that we really try to bring within the company these two legs, right? Something that's really fundamental, almost fundamental research. On the other hand, very, very concrete application, and try to have something in the company that allows to actually go very quickly from one to the other.
Thank you. So facing this scaling up challenge, the deployment and production of unmanned system is very at the core of everything in defense. Philippe, from your expertise at Capgemini, what strategy could help streamline production and deployment across European countries?
So, thank you. So, to streamline UXV production and deployment across Europe, I think we must embrace both hardware and software issues. So yes, hardware scaling matters, and I think Antoine could speak about the acceleration of production of drone within Helsing. In France, there is an illustration also that with Renault, which has partners, so recently with Turgis et Gaillard under the supervision of DGA to manufacture military drones and to leverage automotive-grade industrial engineering and ramp up capacity. So reported ambition include very high target outputs when the line is mature. So here, it's not about turning cars into drones. It's about transferring the best practice from the automotive industry, like design to cost, like repeatable assembly, like industrial test benches. And more globally speaking, we must improve engineering if we want to compress the lead time. So first by building end-to-end digital continuity, so from requirements to manufacturing, and to address production constraints from day one and not to discover them at the end, by using GenAI and agentic tooling to accelerate documentation, to accelerate requirements management, design optimization, configuration management, and so on. And also maybe by standardizing some hardware components. Now, if we focus only on hardware, we will hit a ceiling fast. We must, in Europe, tackle what we call the software debt or software fragmentation. Because on one hand, we have drone manufacturers building the same software foundation again and again. And on the other hand, we have armed forces ending up with several mini ecosystems which are incompatible with different ground control stations, different C2 data formats, cyber baseline, or training pipelines, and also ending up with the costly recertification every time they want to add one platform or to add one capacity. And at the end of the day, it makes the fielding slower and the collaborative combat weaker, because the systems cannot act as one coherent force. And therefore, what we support here is the development of what we call in Europe sovereign, unified, and open software backbone, so a kind of common core which will separate what can be shared. So, for instance, the data formats, some security features, cyber, and so on, to separate this from what should remain competitive. For instance, some autonomy processes, some autonomy models, and so on. And with this approach, we can speed up integration and upgrades. We can reduce certification and cyber rework. We can enable reuse of some autonomy modules. And at the end, we can achieve true interoperability across multi-domain.
Sandra, as an investor, what are the key bottlenecks that you see in the European ecosystem of startups that can address these challenges?
So, first of all, maybe a step back, because when I started to raise this fund, it was almost 4 years ago. And 4 years ago, we commercialized, let's say, an aerospace and enabling technologies fund. So first of all, defense were absolutely not on top or on the first page of our deck, I would say. And 4 years ago, I also supported one of our startups that I followed for many months, doing a brilliant AI and robotics system for the Ministry of Defense and some special forces units. And I went with them to the court because they went bankruptcy because of the lack of orders and the lack of coordination within the Ministry of the Armies about the strategy around drone, AI, etc. So 4 years after, what we see on the market, it's first an immense, huge opportunity in this area, thanks to the progress we do technologically speaking, but also the market that is much more attractive. We see, especially in Europe, due to the fantastic research that we have, that the investment in defense from 2025 was a record year, so 55%. I saw the number this morning from NATO, 55% more investment in European defense startup. And if you do a market sizing, what we do as an investor, the drone robotic AI market is huge. So we estimate around 4 to 5 billion euro for next year, and 10 times more within the next decade. So still, as an investor, what we need actually, we see that the technology is there, the teams is there, the market is attractive. What's the bottleneck for us is to address the fragmented demand, actually, for this market, the procurement processes that are still far too slow, and yes, stabilize a little bit this demand within the European market, and stop to split the budgets, the research and the startups across Europe.
Thank you. Philippe, you already told about the importance of interoperability. So how do you, what are the necessary standardized building blocks to make it real?
Yes, so the issue is that even so some NATO standards already exist, we can see in Europe that interoperability at scale remains too often a patchwork of adapters and duct tape. Once you go beyond one single platform, one single nation, or one single vendor ecosystem. And so if we want unmanned systems to behave like one coherent force, I think we should standardize a small set foundational building blocks. And here is what is my priorities: to unlock speed without killing innovation. So first, for me, there will be a common language of warfighting. Because if platforms don't share the same meaning of what is a track, a target, of mission intents, so you can connect these systems, but you cannot compose them. And the semantic backbone is what will allow sensors, effectors, autonomy functions to plug in without bespoke translation every time. So Europe needs an open and evolvable open data model plus operational ontologies. So second, it's about a standard contract for AI modules. From my point of view, AI should not come as a monolith welded to one platform. We need interchangeable AI modules, so for sensing, reasoning, operator copilot, and so on, with clear input-output schemas, performance metadata, and safety constraints. And that would allow us to swap the model while keeping the integration. And with that approach, we can scale up the upgrade, speed up the upgrade, while keeping the innovators free to innovate on their differentiators. Third, we need portable mission apps with a common runtime pattern. So, for instance, sensor tasking, teaming behavior should come as deployable mission packages. Because with that approach, if missions software is portable, so fielding becomes a matter of install and configure rather than rebuild and reintegrate. And fourth, we need a trusted marketplace with a delivery pipeline for defense software because reuse only works if it is governed. We need clear policies, we need signed artifacts, we need rollback. And if we don't do that, so every vendor will each time redevelop its own app store and fragmentation will come back immediately. And because we are also in the defense domain, so we need also to share some cybersecurity features and assurance and certification patterns. So my key message here is not to say that we have to freeze innovation, that's the other way around, because with that approach, we standardize the foundation and we leave the innovator free to focus on where they can bring a true added value.
Antoine, do you want to add your approach?
Yeah, thank you. Yeah, I mean, I think Philippe is right in the approach, but also when you're a new entrepreneur in this space and you have to enter this world, I can tell you it's a bit daunting as well in terms of all the layer of complexity that is to actually plug in. And I think that's one of the things we need to lift as well, is that when you're a new team coming from a lab or coming from a startup and you want to make an impact, and I think your example, Sandra, is you have one very close, but there are actually many like that, unfortunately, right? Many. In the drone, in the hardware, also just in the pure software space as well, for defense. This, you know, Philippe, and you know that it needs to be simpler and faster, right? I mean, otherwise, you know, you need immense amount of funding to just like power through the whole thing while keeping the pace of like innovating, just to try to swallow a little bit the complexity. So, so my view on that, but at the end, Philippe is right. It needs to work like that. But I think what we try to do at Helsing in this ways is if you want to create new capabilities, and that's what we try to do, right? To go closest to the mission, more autonomy, because Josef said it at the beginning, actually a lot of the thing we built, if you don't build a brick of autonomy with the safety and with the confidence and the trust in it, which means that they can do some part of the mission without the direct supervision of a human operator, because we validated that this part of the mission can be carried out with this machine, because all the guardrails are there. This is what autonomy means, right? In some parts of the mission. If you want to push that, you need to, at least for Helsing, we try to be like, we are not interoperable down the line, but at first we try to be very vertical, right? Very vertical. Like for this specific type of mission, I will try to go from A to Z and try to see how far I can push it, right? Otherwise, if you want to just take one part of the mission integrated with the rest, then you need to work with the rhythm and the flow of the other partners. And the other partners, usually they don't work as fast as you, or at least they don't have the same pace. And if you're a newcomer, it's very hard to keep up. So that's the advice also. It took us a long time at Helsing to understand that, right? So it's not obvious as well, but this is how we try. And we feel also this is where we're able to push the boundary, because I think we try to bridge with research, the boundary of autonomy as well, right? How far can you go? What are the limits of this robotic platform? What can't do? And when do you feel that the operator can feel confident enough that he can hand over some part of the mission or not? This is very subtle. It needs to be tested, repeatable, auditable, etc. And if you don't control the full system, it's very, very difficult to do. So we try to go very deep from the screws to the AI models, and try to bring the forces there so that they can test and audit this part. And hopefully, eventually, this will inform also how we make the new framework and the new standards. If it works like that, maybe it should work for other parties like that, right? So that's our approach right now. And so far, I feel we're making some progress.
Thank you. So, as we said, we need confidence, and something that is often related with confidence is open research. So, Cordelia and Josef, in defense and in robotics in general, the cutting-edge research has to be in rapid development, and the balance between open research and the need for priority or classified advances and defenses is something that we have to balance. How do you do that in your own research? Probably Cordelia first, you're more not on the defense side, but how do you work with that? And then Josef?
Yeah, I think basically we're at Inria, it's open research, right? It's funded by contracts, and so basically the research is open, and by definition I think it's important that you publish. As a researcher, you publish what you're doing. You're not there to hide the thing. So and it's good to get feedback, and it's also good for the students, for the promotion. So I think academic research is by default open, so I think there's no discussion about this. And I think then the question is more, how do we collaborate with companies, right? And so this is often not completely trivial, because basically we have to make sure that the parts which we do then gets either just transferred, but then basically they can just read the papers. But otherwise, if we consult with the companies, there has to be some bridge where we then keep some of the things closed, right? Or if there's a collaboration on a certain project, which is essential for the company, we cannot publish on it anymore. This should be just, I think it should be a very small part of the activities of an academic researcher, right? So there can be these parts where we transfer things, but this should be not the majority of the parts. And then, as Antoine mentioned, they have their own R&D department, which they fund, and then it's up to them how much they make open or not. And I think this is a strategic decision for a company, which they have to make. And obviously, the more they make open, the more their interaction there is. But this is not up to academics to decide, right? So I think for me, it's pretty clear. Academics, it's open, and as fast as we can make progress, it's good for everybody. And then how to interact, that's another thing, which, as you said, is often a lengthy process where you have to specify the IP, what's open, what's not open. Unfortunately, probably it's too slow. It should be faster, but I mean, I don't know how to make it faster.
It's getting there. It's getting there.
I'll mention maybe one more model which I'm seeing around me in Prague. So in Prague, there is quite a lot of robotics groups. I think at the university counted, I think 8 or even more. So maybe more than 100, 150 researchers. And the pattern which I'm seeing is that they're creating spin-offs. So I think they do, of course, open research publications, but when they get to something interesting which they feel could be sort of productized, they would do a spin-off. I'll mention 2 which I I know about. One of them has been around for a while. There is a very strong drone team in Prague around Martin Saska. They have the spin-off Fly for Future. They've been doing drones for a while. They've developed a drone which can catch other drones, for example, which they try to. And I think there, now once you're in a company, you can go into this fast innovation cycle, because you can kind of decide what you open, what you not. It's not an open research anymore, and you can kind of incorporate all the, just innovate, test, innovate, and this now becomes the sort of property of the spin-off. And the second company I want to mention, I think it's very recent. It's like a small one, but I think it's an example how like a sort of relatively, I would say, smaller research result can go. I think the robotics teams, they often like competitions. So there are these like worldwide competitions. Usually goes from papers, then they go already to competitions. And I think both these teams, which I mentioned, they actually won like international competitions. I mean, there's something which they feel is like really works in practice. This team has won. This was a DARPA competition in exploring underground spaces. So they have a now spin-off which is doing ground vehicles. So they've developed this one. It's not that big. It has 3 wheels, and it's very robust. So it can go like a black ski slope in the mountains. It can fall into a stream and still go. So I think well, let's see how it goes. But I think if it sort of gets quickly tested, if it works, I think this is one way how we can quickly innovate as well.
So this is a good link to Sandra. Do you think, as an investor, academia is the place to look for innovation, disruptive innovation? And do you have examples of that?
So definitely academia is still and will remain a fantastic source of disruptive technology. But it's far from enough, especially, I would say, in Europe / in France. I think that as an investor, what we are looking for is a return on our investment. So we need an application. I mentioned before the startup that unfortunately went bankrupt. They had a very strong IP. They were integrated in a lab. They were really far ahead, but if there is no market, no demand, no contracts, you can have the best technology ever. This will not be enough to make a product out of that or a company. So, but still, of course, it is important, and I would say 100% of our companies in our portfolio are very close, either spin-off or very close to some institutes, using either the fantastic capacities, test capacities that some laboratories have, and that you cannot have on your own if you're a startup. They are using in France a fantastic tool that is CIFRE. Voilà. So working with PhDs, backed by the government, so that that you don't have to fully pay on your own, and help you to continue to work on really very specific topic. But in parallel, if you have a company, you have to sell your product, and you have some time to decide that your product is good enough and has an application and has a market, and so you go for it. But of course, especially in defense, this is really this balance that needs to be found. And even within the ministry, we really see the difficulty. We have to cross the gap between research and the application. And we see Agence de l'Innovation Défense, our French DARPA, spending billion every year on a research project, but that have no echo within the Direction des Opérations that has the money and the contracts and could help those projects to scale, because the point is the scalability of the project. So yes, it's important, and of course it's important to know you have to be aware as a startupper, especially in those deep tech defense technologies, that it's not if you will be disrupted, it's when you will be your technology will be disrupted. And I think it's Helsing also, you said, at the moment we see more and more project and deck from companies that are developing submarines USV. And I think it's Helsing saying, yeah, don't spend too much time on that. Soon we will see the subsea will have no secret for us. So, yeah, you know.
The transparent ocean.
So you see, you have just to work closely to science, but you have to market your product.
Thank you. So looking ahead, how do you envision the role of AI in robotics and defense evolving over the decade? So to you all, take the lead. What emerging technology excites you the most, and where do you see the biggest investment opportunities? Question for all of you.
Well, I can start. So I mentioned it a few times. I think autonomy is going to be the key driver for many research and many investments. Why? Because this is what allows to actually flip the balance between hardware and people, right? Especially on the battlefield. You don't want to lose too many people, as maybe none. And if you lose hardware platform, it's actually much more okay, right? And we are right now at the cusp where this cusp is talk about some type of affordable mass as well, which is you can produce a lot of drones, in flying, swimming, working, driving, etc. And when you can switch that, well, you don't need to send, and we see that in Ukraine as well, right? The front line actually is much wider than it used to be, right? People are much less, because the drones are actually the one occupying that, which means that you need to have an automatic vehicle to actually cover because otherwise it's very dangerous. So the point being that right now the way it's going is that we're going to do more robotics platform on the battlefield. It's already coming, it's accelerating. The limiting factor now is going to be the autonomy capability that they have, because if they don't have a lot of autonomy, first off, you limit their range because of the jamming, we talked about it, but also you limit the number of one you use, because if you need one or multiple humans to operate each one, to pilot them, etc., then you cannot scale. You cannot scale much more than you have people trained, and that doesn't scale very much, right? And right now, actually, for many drones, it's actually more human than drones because they need to operate them, the logistic, to fly them, to analyze the data, etc. It's actually a lot of human work that goes with each drone, right? The more you go to autonomy, so autonomy to design the mission, autonomy to operate the mission in multiple parts, autonomy to analyze the mission also, which means that did I see some interesting targets, for instance, the more you actually need less human to do that, right? You can scale their time. Maybe to analyze a mission, it used to take 1 day because you have a lot of footage. If you can reduce that to 1 hour, then you free a lot of time, right? And you free a lot of human capital that you can deploy elsewhere. So I feel in Europe we are not going to have a huge much more soldiers, right? I don't think that's what the society wants, and we are capped by that. So autonomy is the way we are going to cope with that bad, actually, robotics platform. And I think this is a big driver. So in terms of the research challenges to get there, Josef and Cordelia, I think they know what it takes.
Okay, so I'll continue more kind of on the research side. What I see in robotics, which really kind of is beginning to change the robotics at the moment, is sort of learning-based robotics. So we are beginning to see, I'm going to say like large language models, but which are not generating language or images, but they are generating now action of a robot. So the interesting thing is that these models can ingest large amount of training data. So I think there is really now a way, or potential at least, to kind of train them from a large amount of training data. The first thing is that there is not much training data for the robots. I think we need to find a way how to make it more data more efficient, how to even where to get the data. And plus, it's like the traditional robotics, you know what the robot is doing, you program it exactly, and you have guarantees. With these models, you have almost no guarantees. You kind of don't know what's going to happen, basically. They can hallucinate, you don't know when they're going to hallucinate. So I think there is really a lot of research which needs to be done to sort of understand this and make it work in real, make it robust. But I think there is a potential to then be able to learn from examples, potentially small number of examples. Like all this kind of you see in chatbots, you could imagine having in a robot, maybe in 10 years' time. So it's the potential, but I think there's a lot of research ahead of us to do this.
Yeah, so I would agree with Antoine that basically autonomy is the main challenge, that you don't want to intervene all the time. And for now, we're, I think, quite far still, right? We can have these things run for specific applications. You can say, go there, do this. But if you just want to have something which autonomously runs around, it can be in the military field, it can be in a household, it can be in a hospital, it can be anywhere, or in a factory. We're still not there, right? If you have very constrained conditions, it's working. And for me, it's kind of now thinking what is exactly the point we want to improve. So I think it's a number of points. So I think today the whole vision system is not robust enough. It's obviously we don't know really how to train in a continuous way, right? Instead of retraining, we would like to learn on the fly how to improve the vision performance. This is something we don't know how to do. We don't know how to generate maps. So for example, if you think of self-driving cars, they have all these HD maps, and that's something obviously in the real world we wouldn't want to map out every forest. This is something very clear where things are missing. And then on the planning side, there's also a huge gap where I think we started to use these VLAs, which Josef said, which is maybe one step forward, but I think it's still much too much building onto the existing LLM structures to be really functional. So I think there's another thing where we really have to rethink how to combine. I mean, there's now the system 1.2 coming up, how to combine these different approaches and have a really good planner which looks ahead. So I think there's still open challenges and we're not yet done, right? So I think for specific applications, probably there is something, but then if you feel like it's not, for me, it's not so much a platform, but like a way of thinking of these things where we can really address them and ingest all the information which we have, which we're not doing today.
A lot of work to do. Philippe?
Okay, so as a former head of the Future Combat Air System and Grand Combat System, I'm an evangelist of collaborative combat and what DARPA popularized as mosaic warfare. So the ability to compose, recompose many affordable and diverse assets into mission packages to deliver an effect at speed. So what excites me the most are the technologies around this approach and how we orchestrate complexity without overwhelming humans. So first for me is orchestration AI for for heterogeneous fleets and swarms. So here it's about multi-agent AI, able to allocate, reallocate tasks in real time in order to negotiate priorities or to deconflict trajectories. Then we have the LLM-enabled human-machine teaming. So yes, the LLM can transform what we call the C2, so the command and control, because they can translate a mission intent, not a mission, an operator intent into plans. They can summarize the situation, they can explain trade-off, and they can also adapt the information to the operator cognitive load. However, we are in the defense domain, so assurance matters. So here, for instance, agentic pattern or hybrid AI patterns can be highly valuable for policy control action and controlled autonomy. So I have no time, but also I have in mind innovative interfaces like brain controlled interfaces.
Sandra,
Yes,
last
so
word.
very quickly, we like to invest in as agnostic as possible technologies, very pragmatic and useful technological brick that can be game changer on the battlefield, but easy to plug in a system, so kind of interoperability, but capacity to be integrated in a more complex system. And also, it's very important, I personally like to support companies that are not positioning themselves against the system. I think that especially in Europe, we don't have the money and the time to play against each other, but I think that there is a virtuous circle that we see on the market with big players, new defense, emerging players that can bring a lot on the battlefield.
Thank you very much. So we are perfectly on time. Thank you so much for all of you. And yes, thank you.